Okay, this is section 10.3. We're talking about mutually exclusive events and Venn diagrams. So we start with a few definitions here. Two outcomes or events are mutually exclusive if they cannot both happen at the same time. An example of two events that are mutually exclusive would be the event of choosing a king and the event of choosing a queen from a deck of cards when one card is chosen. That is impossible. If you're choosing one card from a standard deck of cards, there's no way that you can get a king and a queen at the same time. Therefore, these are called mutually exclusive events. Events that can happen at the same time are not mutually exclusive events. Like, for example, if you were picking one card from a deck, choosing a 2 and a heart on the same card can happen, the 2 of hearts. So those would be events that are not mutually exclusive. A Venn diagram is a visual representation of the relationship between multiple outcomes or events. Here's an example of two Venn diagrams. The one on the left shows two events, event A and event B, represented by the circles, that are mutually exclusive events. This Venn diagram represents mutually exclusive events because the circles that represent events A and B do not overlap. That means there are no circles where both of them can occur at the same time. The Venn diagram on the right shows us not mutually exclusive events because there is overlap between the two circles. And where those circles overlap represent all the possible outcomes where both events are happening at the same time. The intersection of two events is when both occur at the same time. It is indicated by the overlapping regions of the circles and the word "and." So in our two Venn diagrams, the Venn diagram on the right, not mutually exclusive events, has an intersection of events A and B right there, the overlapping of the two circles. And we would describe this section of the Venn diagram as saying A and B because they're both happening at the same time. The union of two events includes one or the other or both events occurring. It is indicated by the interior regions of both circles and the word "or." Okay, so now we're talking about union, and that word union actually should be highlighted in red because that's the definition. One event or the other event or both. That's what the union stands for. So in the Venn diagram on the left, we can represent the union of the two events even though they're mutually exclusive. And in the Venn diagram on the right, we can represent the union of the two events. Here would be one event, event A. Here would be the other event, event B. And of course, the intersection, A and B, would be included in the union. The two words intersection and go together. So when you hear the probability of event A and B, that means you're looking for the intersection when they happen at the same time. The two words union and or go together. When you hear the probability of A or B, it could be A, it could be B, or it could be both. All right, our first example. It says, of the 100 students in 9th grade, 57 are enrolled in geometry, 33 are enrolled in honors geometry, and 10 do not take a math class. Draw a Venn diagram that shows the enrollments in math class for 9th graders. So we start with a rectangle. This rectangle represents all 9th graders. As a 9th grader, some 9th graders take geometry. So we'll have a circle that represents the students that take geometry. Other 9th graders, and let's actually label it, it says 57 of them are enrolled in geometry. Then we have 33 9th graders there that are enrolled in honors geometry. And we know that you cannot take both courses at the same time, so these are mutually exclusive events, so the circles do not overlap. Now, if you're not in the geometry circle, and you're not in the honors geometry circle, you are one of the 10 students that does not take. I'm just going to put a little 10 out here in the corner to represent them. Now on this slide, we have our Venn diagram that we created on the previous page, and we're being asked to find some specific probabilities. So this is going to show us how you can take the information from a Venn diagram and find the probability from it. So it says, find the probability a student takes the following. In part A, geometry. We get 57 students to take geometry out of 100 total students. Part B, what's the probability that student takes honors geometry? 33 out of 100. Part C, what's the probability that a student takes geometry or honors geometry? Now this is where we are seeing the word or, and as we said, or represents the union. So what this means is we're finding the probability that a student takes geometry or honors geometry, either one, right? So in part C, we add the 57 geometry students plus the 33 honors geometry students to get 90 out of 100, which will reduce to 9/10. Now we come to part D. Find the probability that a student takes geometry and honors geometry. And I emphasize the word and because now this means the intersection. If a student has to actually be taking both classes at the same time, we know that that's not possible because these are mutually exclusive events. So the probability of that happening is 0. Okay, so what we just experienced is the addition rule for events. If N1, N2, N3, and so on represent mutually exclusive events, then the probability that any event in this collection of mutually exclusive events will occur is the sum of the probabilities of the individual events. Okay, this is a little bit wordy, but let me show you how this pertains to what we just did. In part C, we took the probability of being in geometry, 7 over 100, and we added the probability of being in honors geometry, 33 over 100, to get 90 over 100 for part C. That's the addition rule that we are stating right here. If two events are mutually exclusive and you want to find the probability of one or the other happening, take the two probabilities of each and add them together. Here's a second example. Of the 100 students in 12th grade, 70 are enrolled in mathematics, 50 are in science, 30 are in both subjects, and 10 are in neither subject. Draw a Venn diagram that shows the enrollments in math and science courses for 12th graders. We start with our rectangle. This rectangle represents all 12th graders. The problem tells us that 70 12th graders take a math class. Now watch how things are going to change as we... Then we have a circle that represents science. And you know what? I have to make my circles a little bit bigger here, just so I can fit everything in. Math, 70 students, 70 seniors took math. Then we have science. And 50 are in science. But they tell us 30 are in both subjects. So we have to change our numbers here, because 30 are taking both. Well, that means 30 of the 70 that are taking math are taking both. So in this section of the Venn diagram is only 40, because there are 40 students that take just math, and there are 30 that take math and science. So together, the 40 and the 30 add up to the 70 that are taking math. And we do the same thing for the science. If there are 50 total seniors taking science, but 30 of them are also taking a math, then that means only 20 of them are taking just science. So the 20 plus the 30 gives you the total 50 students, right? And then, of course, it says there are 10 seniors that are in neither subject. So they go outside of the circles altogether. Okay, so here is the Venn diagram that we just created, and we're going to use it now to find some probabilities. Find the probability a student takes the following. Math class. Comes out to be 70 out of 100, which reduces to 7/10. Part B, a science class. 50 out of 100, which reduces to 1/2. Part C, only a math class. There are 40 students out of 100 that take just a math class. 4/10 or 2/5. Part D, only a science class. That's going to be 20 out of 100, 2/10, which is 1/5. A math or a science class. This is 80 out of 100, or 9/10. And then part F, the probability that a student takes math or science and is the intersection. There are 30 students that take both, 30 out of 100, or 3/10. All right, that brings us to the general addition rule. Listen carefully. If n represent event 1 and event 2, then the probability that at least one of the events will occur can be found by adding the probabilities of the events and subtracting the probability that both will occur. Okay, so let me explain how this rule actually works. This rule is the addition rule for events that are not mutually exclusive. Which is just like the example we did on the last slide. Let me show you here again, where we knew that there were 70 students enrolled in math, 50 in science, and 30 in both, right? So let's say what we did in this example is we used the Venn diagram, which was a visual representation of how the students were split up. But if we were given that information, that 70 students were in math, 50 students were in science, and 30 students were in both, then what we would do to find the probability that a student took math or science, we would take the probability that they took math plus the probability that they took science minus the probability that they took both math and science. So let me show you how this works out. The probability that a student took math, we said, was 70 out of 100. The probability that a student took science, we said, was 50 out of 100. Now, the problem with just adding those two probabilities together is that we are counting the 30 students that took both math and science twice. Those 30 students are counted in this 70 and this 50. And we don't want to count them twice. We only want to count them once. So what this new rule tells us is that we have to subtract those 30 students one time. So we end up with 70 plus 50, which is 120, minus 30, which is 90 over 100, or 9/10, which you can see is the same answer we got previously over here when we found the probability of the union of math or science.